All right, everybody, today's lesson is going to be on equivalent ratios. This comes from the Big Ideas Math Green textbook, Chapter 5, Section 1. The definition of an equivalent ratio or equivalent ratios are ratios that name the same comparison. So I'm going to try to really help you make sense of that today. So our first example here is we have a ratio of red to blue dots, 3 to 2. So an equivalent ratio, to kind of arrive at an equivalent ratio, there's two ways we can do it. So this first way is the way a lot of students try to do first, and it usually confuses them, is students really think that, oh, well, if I add a red dot and I add a blue dot, I'm following that ultimate rule of math, and what I did to one, I did to the other. However, did we create, if our original ratio was 3 to 2, does this next group that we've added on, does that match the 3 to 2 ratio? And hopefully right away you say no, because it does not. So we have to be careful, because if you're going to use addition and subtraction in a ratio, is you actually are going to have to add or subtract the ratio. So what I mean by that is we can go back to kind of the definition we've talked about before of there are 3 red for every 2 blue. So if I want to continue working with this ratio and adding to it, I actually am going to have to add 3 reds. Okay, and there's no way around that. If for every 3 red, there are 2 blue, and then for the blue, I would have to make sure I've added 2 blues. Now when we look at these two groups of dots here, we can see we've created another duplicate of our original ratio. Now, when we count them all together, we have an equivalent ratio of 6 to 4, because we now have 6 reds and 2 blues. I can do this same duplicating process again. So help me out here. I want to add some reds to this. How many reds do I need to add at least? Or how many reds at a minimum do I have to add? Hopefully you said 3. So I'm going to duplicate this and get 3 more reds in here. Now if I add those 3 reds, help me out, fill in the blank again, how many blues do I have to add? Hopefully you said 2 blues. So I'm going to add in 2 more blues. Okay? Did we create another identical copy of this ratio? Absolutely. Again, looking at all 3, you should see we have 3 duplicates of our 3 to 2 ratio. I cannot just add 1 red and 1 blue, or 2 reds and 1 blue. I can't take these other numbers. Now, as I'm continuing on, I could add 9 reds onto this ratio, because I have 9 right here. If I add 9 reds, how many blues am I going to have to add? Hopefully you said 6. So you can always add a past ratio to it as long as you know its parts. So I'm going to add in our current one. We also have 9 to 6 up here on the board. The next thing I want to talk about is, what if you didn't use addition and subtraction? What if you wanted to think about this as multiplication or division? So if we kind of look over here at the ratios that we've written down instead of at our visual, you actually can look at this and go, hey, didn't we just do times 2 to go from 3 to 6? Absolutely. And this is that rule of math of what you do to one, you do to the other, because what's 2 times 2? Hey, look, it's 4. Now for the next comparison, I might look and go, okay, well, how can we go from 3 to 9? Oh, that would be times 3. So what am I going to do? Well, I'm going to do 2 times 3. Now, one thing you might be thinking is, well, couldn't we have just done 6 times 2? Because we did this times 2 here. It doesn't always work like that. Especially with equivalent ratios, we can kind of just multiply and get bigger as many different ways as we want. Let's continue on to the next slide and really kind of dig deeper into this multiplying ratios bigger. For this next example, it's similar to the last one we have, but a little bit different. And I'm not going to give us a visual this time. I want you to pause this video, and I want you to write down or to think about 3 equivalent ratios to 2 to 3. And I'm not even giving it a context of boys or girls or blues or red dots or whatever it is. I just want you to tell me 3 equivalent ratios to 2 to 3. Keep it simple. Pause this video if you haven't already. Let's see what you can do. Hopefully by now you have 3 ratios written down. Let's see how yours compare to mine. So the first one I'm going to do is I'm going to start simple, and I'm going to take this ratio 2 to 3, and I'm going to multiply both parts by 2, which would give me the equivalent ratio of 4 to 6. Did you write that one down? For my next equivalent ratio, I'm going to do, let's say if I just wanted to go really simple, I'm going to do times 3 now. 2 times 3 is 6. 3 times 3 is 9. Okay. How about that? Did you write that one down? For my next one, maybe let's go a little bit bigger. Let's do 2 times 10, which would be 20. 3 times 10 would be 30. Did anyone write that one down? Okay, let's maybe go to an odd number. Let's maybe do times 9. So if I do 2 times 9, that gives me 18, and 3 times 9 gives me 27. Now, you most likely or probably have different ratios than I do. And as long as you multiplied both parts of your ratio by the same number, your ratio should be correct. That's the thing when naming equivalent ratios. There's endless number of equivalent ratios. But in our next problems, we're going to get a little bit more specific. This problem is still an equivalent ratios problem. It's just a little bit more specific. So it reads, if there are 5 boys for every 6 girls, how many boys are there if there are 36 girls? So the way I'm going to recommend you solve these types of problems is I want you to start by writing the ratio, and this time I'm going to write that ratio in fraction form. So 5 boys for every 6 girls. I'm going to write it this way. Now, this ratio, we have to make it into the ratio where there's 36 girls. And I'm going to put 36 on the bottom because, again, the girls part of our ratio was on the bottom, so 36 goes on the bottom. How now do we go from 6 girls for every 5 boys to 36 girls? Hopefully, using our math facts, we can all identify this would be a simple times 6. So the ultimate rule of math, what we do to one, we do to the other. We would also have to do 5 times 6. That means there are 30 boys if there are 36 girls. For this next problem, I want you to try to solve it first. The question reads, the ratio of chocolate milk to white milk is 5 to 2. If there are 18 white milks, how many chocolate milk is there? Pause your video now and try to solve before I do. Hopefully you've taken the time to solve it. I'm going to begin now. The first thing I'm going to do is write my ratio. The ratio of chocolate milk to white milk is 5 to 2. So I'm going to write this in that fraction form again. You don't have to write it in this form, just the way I like to when trying to solve for equivalent ratios. I know I need to get to 18 white milks. Again, white milk was second in our original ratio, so this 18 is going to go on the bottom here. I quickly recognize that to go from 2 white milks to 18 white milks, I would have to multiply by 9. What I do to the one, I'm going to do to the other. That means there would be 45 chocolate milks. Just like that. For our very last problem in this lesson, I would like you to pause the video and try to solve by yourself. Please do so now. I'm going to begin solving now. For every 4 roses, there are 3 daffodils. If there are 60 roses, how many daffodils are there? So to begin, I would write my ratio of 4 to 3. They didn't explicitly say the ratio is, but we should know that for every 4 roses, there are 3 daffodils. That is another way of saying the ratio is 4 to 3. For this particular problem, they tell us there are 60 roses. Well, roses were the first number in the ratio, so I'm going to put 60 on top. How do we get from 4 to 60? That would be times 15. And if you didn't know that off the top of your head, you actually could have done 60 divided by 4 and found that it's that times 15. So that is a little trick, is if you divide those two numbers, then kind of work the other way, it tells you what to multiply by. On the bottom, we would do 3 times 15 to keep that. What we do to one, we do to the other. That tells us there are 45 daffodils. Making sure that we add a label to our answer because it's a word problem. That's it for today's lesson. I hope you understood. If you have any questions, please let me know.